Welcome back to our videos on the 3B4 notes discussing atomic number and mass numbers. In our last video, we finished with example 6 where we looked at how many electrons an atom gains or loses based on the charge that is written there. One thing we need to keep in mind that when an atom actually has a charge and is an ion, and it's written number followed by the charge. That's the convention. So 3 plus means that the ion is 3 plus. Plus ions are called cations. They are positive, and they're positive because they lost negative things. They are left with more positives than negatives. So this means that aluminum, which is plus, must have lost 3 electrons. We also learned that that makes sense when we look at the periodic table of elements. That makes sense when we look at the periodic table because aluminum starts with or has 13 protons, which means it starts with 13 electrons. If it loses 3 electrons, it would have 13 protons, 13 positives, and it would only have 10 negatives. So there's 3 more positives than negatives. That's what the 3 plus means. There's 3 more positives than negatives. So now it only has 10 negatives. Neon has 10 negatives. Neon is a noble gas, an inert gas. It's chemically stable. So when aluminum loses 3 electrons, it'll have the same number as neon. So it will also be chemically stable. It is not neon. And that's something that's important to note. It didn't lose 3 protons. If aluminum lost 3 protons, then it would be neon. Neon's any atom with 10 protons. Aluminum is any atom with 13 protons. But you can't lose protons in chemical reactions. You can only lose those in nuclear reactions. Likewise, we also discussed about the negatives in our last video. O2 minus, number followed by charge, means that oxygen has gained 2 negatives, which means it now has 2 more electrons than protons. So how many electrons would O2 minus have? It's called the oxide ion. When you gain electrons, they put an "ide" on the end. So how many electrons would the oxide ion have? If you have a periodic table of elements, it's easy to find out. Here's oxygen right here. Oxygen starts with 8 electrons. If it gains 2 negatives, it would now have 10 electrons, and it would be chemically stable like neon. So we could see why O likes to become the oxide ion. It likes to gain 2 electrons. It would have 8 protons and 10 electrons. It would have 8 positives, 10 negatives. When you try to balance out 8 protons with 10 negatives, you have 2 more negatives than positives. Thus the reason it's written O2 minus. So we kind of quickly reviewed that because we keep referring to the periodic table here. We say that they're trying to end up with the same number of electrons as the ones over here. So how could hydrogen get the same number of electrons as helium? It would mean hydrogen would like to become 1 minus. It would like to do that. If it becomes 1 minus, it would have the same number as helium. And now you see why they have it called the octet duet rule. Some atoms will try to end up with 2 like helium. Hydrogen can also lose an electron like everybody else in its family. Lithium can lose 1 electron. It starts with 3. It can lose 1 electron and become like helium, satisfying the duet rule. Sodium can lose 1 electron and become like neon. 11 minus 1 is 10. It turns out that this whole first column likes to become 1 plus. How many would beryllium have to lose to become like helium? It starts with 4. If you take away 2 negatives, it would be left 2 positive because it has 4 positives, starts with 4 negatives. If you get rid of 2 of the negatives, it would have 2 more positives than negatives. It would be 2 plus, and in so doing, 4 minus 2, it's like helium. As it turns out, boron would have a lot of trouble. Boron is just not very good at losing 3 electrons. Boron, if it lost 3, would be like helium. It's not very good at doing it. Aluminum is not bad at losing 3. If aluminum loses 3, 13 minus 3, it would leave it like 10. So the ones down here, these green ones on this table, they can lose 3. The orange ones lose 2. The red ones, including hydrogen, can lose 1. Notice that the blue ones over here, fluorine would need to gain 1 to be like neon, fluoride, and become the fluoride ion. Fluorine likes to become the fluoride ion, gain 1 electron. Chlorine likes to gain 1 to get 18. Bromine likes to gain 1 to get 36. Iodine likes to gain 1 to get 54 and become like the noble gases. Group 17 likes to become 1 minus. Group 16 right here, oxygen, sulfur, selenium, tellurium. Oxygen needs 2 to get like neon. Sulfur needs 2 to get like argon and become sulfide. Selenium needs to get 2 and become like krypton, and it'd be called selenide. Tellurium likes to get 2 to become like xenon. This group 16, at least this upper part of it, all becomes 2 minus. When the colors change down here, they have trouble getting 2 to become like the next one. Nitrogen needs 3, become the nitride ion, ends up like neon. Phosphorus needs 3, 15 plus 3 is 18 like argon. Arsenic needs 3, become arsenide, like getting 3 would become like krypton. These ones right here tend to like to gain 3 electrons and become 3 minus, group 15. 15 plus 3 takes us to group 18. 16 plus 2, 18. 17 plus 1 takes us to 18, the number written right here. This is kind of summarized on what we call the periodic table of ions. The periodic table of ions. If we look on our next page of notes, we have the periodic table of ions. On this table, we see the group numbers, group 1, group 2. These are group 3 through 12, group 13, 14, 15, 16, 17, 18. When we're talking about a group, we're talking about that vertical column. But they are also numbered Roman 1, Roman 2. So when we look at this table, hydrogen is also called Roman 1. Those are family numbers. Beryllium's column, group 2, is Roman 2. Boron's column is Roman 3. Carbon's column is Roman 4. Nitrogen's column is Roman 5. Oxygen's Roman 6. The halogens, fluorine, chlorine, they're Roman 7. And these guys are Roman 8. Why? 8 is for the octet. 7, Roman 7, they need 1 to get 8. They're 1 minus. Roman 6 needs 2 to get 8 like the octet rule. They like to become 2 minus. Roman 5 needs 3 to get 8. They're 3 minus, 3 minus, 3 minus, 2 minus, 2 minus, 2 minus, 2 minus, 1 minus, 1 minus, 1 minus. These are all minuses. These are all nonmetals. Nonmetals are elements on the right side of the table. Nonmetals are very good at forming negative ions. The noble gases do not need to form ions because they already have 8. The stair-step line separates the ones that can become minus in the vertical column, which we call a group or family, from the ones that can't become minus. And we'll learn later this year that some of them can't become minus, even though it would seem like it would help them. And it has to do with the size of the ions, and we'll get that to the later. Earlier, we mentioned that boron, atomic number 5, it would be nice for boron to try to gain 1, 2, 3, 4, 5 to be like neon. It would be easier, though, to just lose 3 and become like helium. 5 minus 3 is helium. It has trouble doing it. Carbon looks like it could gain 1, 2, 3, 4 and become 4 minus to get 10. Or it could lose 4. 6 minus 2 is 2 and become like helium. It has trouble doing it. Silicon also has trouble gaining 4 or losing 4 to become like neon, gaining 4 to become like argon. So I put these in blue because they have trouble gaining or losing electrons. They're much better at sharing electrons. Aluminum, though, is able to lose 3 and become like neon. Over here, these are the ones we mentioned earlier. Roman 2. Roman 2 likes to become 2 plus. The left side of the table, the left side of this orange line are what we call the metals. The metals lose electrons to gain stability. The nonmetals gain electrons to become stable. So the left side of the table is where we find the metals, and they are better at being positive ions or cations. If beryllium loses 2, it satisfies the duet rule. It ends like helium. If magnesium loses 2, 12 minus 2, leaves it like neon. Octet rule. All these down here, that Roman 8's there is because they all do the octet rule except helium, who's really small and it doesn't need to. This family right here, Roman 1's, they could all lose one. 37 is rubidium. It can lose one. 37 minus 1 is 36. It would leave it stable, like krypton. Hydrogen can lose one and sort of become stable with none. I guess I say sort of stable. Hydrogen would rather gain one, which is why it's written over here. It would be called hydride. When hydrogen gains one, it satisfies the duet rule. It can't always do that, and it can lose one and end up with no electrons. Hydrogen starts with one proton, one electron. It can lose one and be left with none. This is the periodic table of ions. It's a nice little resource, and now you understand why they form the ions that we were working with when we or introduced when we were talking about mass number and atomic numbers. And that takes us to our final question, example number 7, cadmium. This is the nuclear symbol for cadmium, and it wants us to use this nuclear symbol to answer several questions about it. Remember, the nuclear symbol format has the mass number on top and the atomic number down here. The mass number tells us the number of protons and neutrons. So cadmium in this isotope has 112 particles in the nucleus. All cadmiums have 48 for their atomic number, 48 positives. And there, it's right here. There's cadmium. 48 is its atomic number. So here we go. What's its atomic number? 48. That's the atomic number right there. Question 2. What's its mass number? That's the mass number right there, 112. How many neutrons does it have? The mass number gives protons plus neutrons. The atomic number just gives protons. So, for question 3, how many neutrons does it have? Take the mass number minus the atomic number. Mass number is protons plus neutrons, 112. Of those 112 particles, 48 of them are protons. 112 minus 48 means 64 of them must be neutrons. Question number 4. How many electrons would a neutral atom have? Question number 4. For a neutral atom, for an atom to be neutral, the positives must equal the negatives. So if it has 48 protons, it has to have 48 electrons. Cadmium is famous for being 2+, as we see right here in this square. Cadmium is famous for being 2+. How many electrons does it have when it's 2+? Well, if it starts with 48 electrons, or if it starts with 48 electrons and it's 2+, plus means it lost 2 electrons, so it now has 46. Cadmium is a metal. It's on the left side of that orange line. Metals tend to lose electrons. There's that orange line. The metals are to the left of that. So it makes sense then. 48 minus 2 is 46. What's the correct hyphen notation? Hyphen notation is the symbol followed by a hyphen and the mass number. So it would be cadmium hyphen 112. Cadmium hyphen 112. How many nucleons does cadmium 2+ have? Well, the 2+ has nothing to do with nucleons. The 2+ has something to do with electrons. So how many nucleons would it have? Nucleons are the protons and neutrons, and that's given by the mass number. It has 112 nucleons. Which of these symbols is an isotope? Which of these symbols is an isotope of cadmium? Isotopes are same number of protons, different number of neutrons. So our symbol up here has 48 protons. So we're looking for an answer with 48 protons. Letter D has 48 protons. Letter A has 48 protons or atomic number. So it's either A or D. But an isotope has different numbers of neutrons. This one has 112 protons and neutrons. So the isotope would have to have a different number up here, 114. Isotopes are atoms of an element that have the same atomic number and different mass number.